Welcome to lecture 5. In this lecture, we will see how the standard form of a straight line looks like, and we will reduce that standard form to the various forms which we have discussed in the previous class, such as a slope intercept form, and the normal form. Now, we all know that ax plus by plus c equals to 0. This is an equation. This is general equation of first degree with two variables. The variables are x and y. We have solved many of these in the earlier cases. If you draw the curve of this ax plus by plus c, it represents a straight line. Its curve is a straight line. But we have learnt in the previous class that the equation of a straight line looks like different forms under different conditions. We have seen for a slope intercept form, the line looks as y equal to mx plus c or m into x minus c. Or for an intercept form, we have seen that x by a plus y by b equal to 1. For a normal form, we have seen that x cos theta plus y sin theta equal to p. Now we will reduce the standard form to those three forms. First form is slope intercept. We are not reducing this general equation into the point slope and 2-point form. Why? Because for a slope intercept form, we need slope and intercept. So we know that for a line, slope and intercepts are unique. We can have a single slope, we can have a single x-intercept, we can have a single y-intercept. Similarly, if you take for point slope form, we need a point and we need a slope of a line, whereas slope is unique, but the point is not unique. For a line, we have infinite points. So for different points, we will get different reduced forms. So we are not doing that. Similarly, for a 2-point form, we need 2 points. We can take any 2 points because there are infinite points on a line. So we can take any 2 points. Then the reduced forms will be many. So we are reducing it to a slope intercept form. We know that slope intercept form looks like y equal to mx plus c, where c is y-intercept. So now we will reduce it to the slope intercept form. We know the general equation is ax plus by plus c equals 0. I will take x and c to the RHS, and I will write in terms of y, which case by equals minus ax minus c. That implies y equals minus a by b into x minus c by b. Now if we compare this equation and this equation, we can say that slope is m equals minus a by b, and c, which is y-intercept, equal to minus c by b. Again, we know that y equal to m into x minus c, where c is x-intercept. If we compare these two, I will write here. If there are both two c's, so it might get confused. We will write y-intercept. Y-intercept equals minus c by b. Similarly, if we compare with this equation, we get m equals a by b. We have a unique slope, so m will be minus a by b, whereas m into c, minus m into c equals minus c by b. That implies c equals c by bm. This is capital C. C by b. What is m? Minus a by b. A by b. BB gets cancelled. We get minus a by c. This is x-intercept. So we reduced the general form to the slope-intercept form. If we reduce, we will get slope as minus a by b and y-intercept as minus c by b, x-intercept as minus a by c. Now we will reduce it to the second form, which is intercept form. Intercept form. How does intercept form looks? X by a plus y by b equals to 1, where a is x intercept, where b is y intercept. X is intercept. What do you mean by intercept? Intercept is nothing but the point, the length of the point from the origin where the line intersect x-axis is x-intercept, and the length of the point from the origin where the line intersects y-axis is y-intercept. Now we will reduce the general form to the intercept forms. General form is ax plus by plus c equals to 0. I will take c to the RHS. See how I will reduce. Ax plus by equals minus c. To get 1 in the RHS, I will divide with minus c, which gives ax by minus c plus by minus c equals to 1. Now I will take a to the denominator side, which gives a by minus c by a plus y by minus c by b, which equals 1. If we compare this and the intercept form, we get x-intercept. X-intercept equals minus c by a, whereas y-intercept equals minus c by b. If you check with the previous form, we got the same answer. X-intercept is, this is minus c by a. X-intercept is minus c by a and y-intercept is minus c by b. Here also we got the same. We should get the same. Now the third one is normal form. How does a normal form looks? X cos theta plus y sin theta equals p. What is p and theta? P is nothing but length of the perpendicular from origin to the line, whereas theta is nothing but the inclination of that perpendicular. Let's say this y and x axis, and this is a line L. Then from origin to the line, if you draw a perpendicular, then this length is p and this inclination is theta. Let's say this point is some m. If you draw a perpendicular from m to the x-axis, let's say this point is some n, and this is origin O. Okay. Now the standard form is ax plus by plus c equals to 0. If we take c to the RHS so that we can compare both the equations, y equals minus c. If you compare this equation and this equation, you can write as a by cos theta, because the both coefficients should be, all coefficients should be in a proportion to be same, equals p by sin theta, which equals minus c by p. From this we will get cos theta equals take minus c by p to the left hand side, which gives ap minus ap by c, whereas you get sin theta equals minus bp by C. Okay. We all know that a interesting identity between cos and sine, cos square theta plus sin square theta equals 1. So if we substitute cos theta and sin theta in this equation, which gives a square p square by c square plus b square p square by c square equals 1. Now we need to find p, which gives p square equals c square by a square plus b square. That implies p equals plus or minus c by a square plus b square. Now if you observe that p is nothing but the length from origin to the line, perpendicular length. So the distance must be positive. So if c is negative, then p equals minus c by a square plus b square. We have to make sure that p is positive. If c is positive, which gives p equals c by a square plus b square. Okay, we have to make sure that p is always positive because it's the length. Now we will find a and b. From this equation, we know cos theta equals minus a by p. So cos theta equals minus ap by c, minus a into p can be anything. So I will write just c by ac by ap by c. A, this is p. Sorry. P is square root under root over a square plus b square. By ap by c. Which gives cc gets cancelled, minus a by root over a square plus b square. This is when, under this case, because we substituted p as c by root over a square plus b square, which means c is positive. Similarly, we get sin theta equals minus pp by c, which gives cc gets cancelled, which gives minus b by root over a square plus b square. So if you substitute cos theta sin theta p in this equation, we get x into, what is cos theta? Minus a by root over a square plus b square plus y into, what is sin theta? Minus b by root over a square plus b square equals to p. What is p? We have considered this case. So p is c by root over a square plus b square. If c is negative, then we have to substitute p equal to minus c by root over a square plus b square. Then minus gets cancelled. We get cos term as positive and sin term as positive. So I will write that case also, which gives x into y into equals minus c by root over a square plus b square. If c is positive, if c is negative, so we get two reduced forms based on the condition of c. See, this equation is nothing but we have to divide the general form with root over a square plus b square. A is x coefficient, b is y coefficient. Suppose example, reduce 2x plus 3y plus 1 equals 0. Here c is positive, so we need to divide this equation, this is a, this is b, with root over a square plus b square. What is root over a square plus b square here? Root over 4 plus 9, which is root 13. So we need to divide this equation with root 13, which gives 2x by root 13 plus 3y by root 13 plus 1 by root 13 equals to 0. Now we have to take this p to the right side or left side, such that it remains as a positive quantity, which means minus 2x by root 13 minus 3y by root 13 equals to 1 over root 13. We need to keep this p as a positive, because that is how we define the normal form, where p is the length from origin to the line, so it must be positive. So this is the normal form. This is general form. So we reduced by dividing it with the root over a square plus b square. Thank you.